Go.
Disclaimer. This chapter is weird.
Is it hard?
It's kind of hard. And the only reason why it's hard is because it's not a lot of math that you're used to. It's gonna kind of feel like you're almost in an English class. You do more writing than more like computing.
I'm gonna follow this way.
All I'm just saying is it's gonna be weird, and once it clicks, it will click and it will make sense. But it might take a while for it to click. So just promise me you're gonna try until it clicks, okay? Okay. Our first word.
Sophie.
Inductive reasoning is making a conclusion based on observations and patterns. So you're just going to be given a series of either pictures or numbers, and based on what you're given, you can make a guess of what's going to come next based on observations and patterns. A conjecture is just a concluding statement using that inductive reasoning. Or I like to call it an educated guess. What would be a smart guess based on what you're given? Like I could say, it's been around 60 degrees the last few days. What would be an educated guess what the temperature will be tomorrow? About 60. That would be
-2.
That would be a non. That'd be a really bad educated guess.
100.
Way out of way wrong.
We live in North Dakota.
Yeah, you never know.
Our state is very bipolar.
Yeah.
Indeed.
Okay, so we need to write a conjecture, and based on this educated guess, we have to figure out what the next number is in our pattern. So we're looking, how do I get from 38 to 31?
7.
Minus 7, right?
Yes.
31 to 24?
-7.
24 to 17?
-7.
So what is our conjecture?
10.
-7.
So we get 10, but what would we write here? What would our conjecture be?
-7.
Decreases by 7. Yep. Good work. Okay, same idea. This time we're talking about months.
It's 2 months.
So February, May, August.
February, March, April, May, June, July, August.
It's 3.
So what do we guess? But we don't double a month.
Every 2 months.
November.
Oh,
that would make sense.
November.
August,
December.
September, October, November. It's
So November.
Not 2. Yeah, come on.
Excuse
And
me.
every what month?
Third.
Every third month.
I think I understand this.
It's kind of like when we, like the first thing we learned when we were youngins. It's like, hey, you got 1 and then you got 3. What's the difference?
Exactly.
You're adding 2 every time.
So these are like nice, easy ones, and now we're going to get into some more interesting ones where you have to maybe think a little bit more about them,
Rate.
which is fine. We can handle it. Okay. The sum of two numbers, excuse me, the sum of two odd numbers.
Oh, it is even.
Oh, it's always even.
It's always even.
Oh,
Do you guys agree?
yes. It's always even. This is true.
Results in an even number.
Yes.
If you're wondering how your classmates figure that out, you have no clue, just guess and check. What is 13 plus 17? 30. That's an even number. What is 7 plus 5?
12.
Even number. So you just guess and check until you've convinced yourself it is what it is. Okay?
Yes.
What about the product of two even numbers? What does that result in?
Even. No.
It's always.
Yes.
Yeah.
It's
Yeah.
not an
Always.
even number.
Yes.
2 times 2. 4.
Is it always even?
Yes.
Yeah, it is.
100%.
Just listen to Glenn. Glenn's always correct.
No, wait.
Glenn is all.
An even number. And then we throw some geometry at you since this is a geometry class.
The relationship between A, B, and EF and A, B, CD, and CD, CF.
Okay, so you're talking about segments here, right? A, B, and EF. So if AB is equal to CD and CD is equal to EF, what do we know about?
AB is equal to EF.
Yeah, is equal to 8.
You guys agree?
That's the same.
I'm just gonna draw it out in case we can't see it. Here's AB. Let's say it's 5 units long. And here's CD. And if they're equal, what would this have to be?
5.
And then I have EF. And if EF's equal to CD, what's this guy?
5.
So what do I know about AB and EF?
They're equal.
Okay. And then we have this thing called a counter example, and that is when you can prove something's false by having something that makes it not true. So if you can prove something, one case is not true, then it's not true for everything. So part of your assignment will be given a situation, you have to decide if it's true or false, and that's when you'll use a counter example. So if we have the sum of two consecutive integers is always odd, is that true or false? So I'm thinking two numbers right next to each other, like 5 and 6. Does that always result in an odd number?
Yes.
Yes.
Yes. Yes.
And if you honestly, if you have no idea, like this is weird, you just grab a calculator and you just start trying different things.
Because even and not false.
So Carter says an even number plus an odd number is always odd. Is that true?
Yes.
I agree. So the sum of the two consecutive numbers is always odd. That is true.
So aren't like next tests like true and false questions?
No, not really.
50-50.
Is this like kind of like word problems?
It's just kind of like this. It's just like logic. I think you're just doing a big puzzle all day.
I
Like,
don't
put a positive spin on it. It's just a puzzle.
Puzzles are fun.
No, I like those like 10-piece
Okay, let's try this one.
I like the 10-piece ones.
If the area of a rectangle is 6 square inches, then the dimensions must be 2 by 3.
That's
False.
Why is it
Because it
false?
could be a 1 by 6.
Because that's not how it works.
Because it's not how it works.
But doesn't this 2 by 6
No.
or 2 by 3 give me an area of 6?
Yeah, but you have to be 1 by 6.
But it says it must be. You can get 6
But it doesn't matter, you can still do
Yeah.
Who
it.
cares if it looks
Yeah.
weird?
I care if it looks weird.
You
we're gonna
look weird,
say-
but we still love you.
False,
You gotta play it.
because there's other ways to multiply to 6. Ways. To multiply to 6. Good work. This one's goofy, the next one.
If JK
Okay, let's look. If JK equals KL, then K is the midpoint of segment JL.
Yes, true.
Why?
Wait, no, they could not be the same. Wait, no, they have
Yeah, because they're
be.
equal to each other. Right?
But a midpoint is always like in the middle.
Yeah.
What?
Yeah.
Oh my goodness!
That's okay, that's okay. It's
Well.
Monday morning.
You know, how's your life going right now?
So
pretty
that's
bad.
anybody in this classroom.
So what are we thinking right
That's the
now?
most false.
True.
True?
I'm
Because-
just thinking not that at all.
Because if you draw a line, it's like AB and then BC. It's like JK and KL.
You're
And
just
those
saying
two equal
That was
JL,
not a
don't
right
they?
moment.
It's okay.
So let
It's
me
like
draw what Carter's thinking. So he says here's JL and here's K. And I know that's the midpoint
It's like
because it
learn-
says it's equal.
It's like what we learned last chapter.
Is he right? But do I know they're on a straight segment together?
No.
Did it say?
No, it.
What if it was like a triangle, an isosceles triangle?
Oh wow.
Oh dang.
But it says segment
Oh.
J.
Oh wow.
There's segment JL.
Oh, that's the middle.
Right, because like this could be equal to that.
Tricky.
Is K on JL?
I don't
No,
like
so it's
it.
not a midpoint.
We skip this chapter.
False. This is just a way to think outside the box. I told you it's gonna be
I
weird.
get yelled at this trying to
inside the box.
We all stay inside the box, nothing can go wrong.
Okay, read the next one, see what you think.
Guys, you gotta be positive.
And remember, you can't assume anything. You cannot assume anything.
Of course it is. I just made it up.
No, it's positive, Patty.
I think it's true, so I'm putting false.
But if it's false, you have to provide a counterexample.
Oh,
So just put true.
just put true on it. Oh no. Yes.
They don't have to be across from each other. They could be like one's right here and the other one's like right here. They don't have to be like
Just put it's possible.
They'll find a way.
Wait, so for the last one you said so.
I said don't.
So for the last one you said it never like what did it never say?
It didn't say they were on the same.
They were the
It
same.
didn't say that K was between J and L. That's why.
basically detective.
So I don't know if you guys heard Glenn. He made a good point. So we know vertical angles are what? They're always equal, right? So that's what this is saying here. But does it say they're across from each other? No, because you could have angle A, B, C, and let's say it's 60 degrees. And then you can have this other angle here, D, B, E, and it could also be 60 degrees. Are those vertical angles?
No.
No, but are they still equal?
Yeah.
So it's false.
I'm a genie.
So the only way you're gonna get comfortable or good at these things, guys, is if you just try them on your own.
And
So we have a lot of time to practice these in class. Yes, sir.
Wouldn't the TVs be connected?
It doesn't say.
I lost my brother.
So there's two point Bs.
There could be, or you could draw it like this, and that could be 60 degrees. I mean, it doesn't specify.
But if it was like that, or no,
they're not directly across from each other. 'Cause
No.
one's like 180 and then the other one's like,
Right.
that's
vertical.
that's vertical.
yeah.
If
Come on,
we
Jacob.
if we put through, are we wrong?
What's that?
If we put through, are we wrong?
Yes.